Hello guys, let us see combinations of errors. Now what is combinations of errors? Now here I would define my Z as sum of A and B. Okay. Now for A, what is the accuracy that I am expecting? For B, what is the accuracy that I am expecting? Now here for A, it would be A plus or minus delta A, and for B it is plus or minus delta B. Okay, now what are these delta A and delta B? They are the absolute errors in A and B. Okay, so then what is the error in my Z, quantity Z? So I would say Z plus delta Z. So again it is plus or minus delta Z. That would be equal to A plus or minus delta A plus B plus or minus delta B. Correct. So now obviously my delta Z is going to be equal to plus or minus delta A plus or minus delta B. Correct. So there should be something there. So I would say delta A plus delta B. Now why do I say that? Why am I adding that? Now what is the maximum deviation? Maximum deviation. If delta A and delta B, if both of them are positive, then I get maximum value, and if both of them are negative, I get minimum value, isn't it? So actually here this is something that works better. So maximum value on one side, minimum value on the other side. So anyway, my error in delta Z, it is going to be delta A plus delta B. What if my Z is equal to A minus B? Again, here the spread would be similar. So my delta Z over here as well is going to be equal to delta A plus delta B. And what is the reason? My A has got, I'm going to the negative side, and for B also it is going to be, and now for B it is going to be positive, but then minus delta A plus or minus delta A minus of minus delta B, so that is going to be equal to plus, isn't it? So minus and minus. What about other side? My A, quantity A, is on the positive side. So positive and then negative. So again, if you find the maximum spread of quantities, is going to be equal to delta A plus delta B, right? So this delta Z is equal to delta A plus delta B applies for addition and subtraction both. What about multiplication? Suppose I have I define my quantity Z as equal to A into B. Correct? Then what would be Z plus delta Z? Would be A plus delta A, B plus delta B. Okay, it is going to be plus or minus here and plus or minus here. So if I expand this, it would be AB plus or minus A delta B plus or minus B delta A and plus or minus, now it is plus into minus, plus into plus, or minus into plus and minus into minus. So again, let's not go into all those details. So this is my Z plus or minus delta Z here. Correct. But my Z is equal to AB, so I am going to cancel this. Correct. Same quantities here. Now if I divide both the sides by Z, I am dividing this by Z, and then I'll divide this by AB, AB and AB. Now what happens here? This A is gone, this B is gone over here, and then this quantity, my delta A and delta B, they are both very small quantities, so their product is going to be even smaller, correct? So I'll simply ignore this, correct? So what am I left with? I'm left with this. So I can say delta Z upon Z is equal to delta A upon A plus delta B upon B. And what is delta A upon A? Is it not relative error in A? And what about delta B upon B? It is again relative error in B. So I would say relative or fractional. So I would say fractional error in my Z would be sum of fractional errors in A and B, correct? So I get this relation. Now what if my Z is equal to A upon B? With use of some calculus or derivative, we are going to be able to show that delta Z upon Z over here is also going to be equal to delta A upon A plus delta B upon B, correct? So then here this is the rule for product. It is sum, quotient, again it is sum. Now what if I have some expression like this: Z is equal to A raised to power P, B raised to power Q upon C raised to power R. We can generalize this rule like this, and delta Z upon Z would be equal to delta A upon A into P. P is an integer. P, Q and R are the powers of A, B and C, plus delta B upon B into Q plus delta C upon C into R. So this is a general expression, and this can be used, this can be proved using derivatives as well. Now that's all in this video. In the next video we are going to talk more about, we will be doing some numerical problems in the next video. Thank you so much.